What if the most important discoveries of the 21st century aren't buried deep within the Earth, but instead are tumbling through space above our heads, arriving from places beyond our imagination? For centuries we assumed that Earth existed in splendid isolation, separated from other worlds by distances so vast that any significant interstellar findings were deemed impossible. But in 2017, something barreled through the cosmos at an unfathomable speed, forever shattering that assumption. The object, known as Oumuamua, was unlike anything we'd ever seen before. It didn't behave like any comet or asteroid in our solar system. It moved with such force and at such a speed that it defied the basic laws of celestial mechanics. The implications of its arrival would go on to transform our understanding of the universe in ways we could never have imagined. When astronomers first spotted it, no one knew what to think. Here was an object hurtling toward us from the deepest reaches of interstellar space, entering our solar system at a speed and angle so abnormal it seemed impossible to explain. This was not some rock or ice chunk from our own sun's orbit. It was something that had traveled for millions, if not billions of years across the stars, and was now passing through our solar system as though it had an urgent destination in mind. The initial analysis revealed a strange truth. Oumuamua's trajectory was hyperbolic. In simple terms, this meant it wasn't bound by the sun's gravity like a comet or asteroid should be. It was simply passing through on its way to somewhere else from a place far beyond our comprehension. But it didn't stop there. A further scientist studied it. The stranger it became. The object didn't just move unusually, it accelerated as it left the sun's gravitational pull, without any visible signs of the gas jets typically seen in comets. And its shape, long and thin, more like a cosmic cigar than a simple rock. It was as if it had been engineered, designed and sent here for a reason. So the question arose, was this an anomaly of nature, or something far more mind-bending? Could we be looking at something far beyond our understanding? Something possibly artificial? As Oumuamua disappeared back into the void of space, the world of astronomy would never be the same again. The question of whether we were truly alone in the universe, or if we had just made contact with an intelligent force from beyond our solar system, had officially been raised. And in the years to come, more strange visitors like Oumuamua would appear, forcing humanity to re-evaluate everything it knew about the cosmos. On October 19, 2017, a discovery was made that would ignite the scientific community and set the stage for one of the most astonishing debates in modern astronomy. The Pan-STARRS 1 telescope in Hawaii, a massive observatory designed to scan the skies for asteroids and comets that could threaten Earth, made an observation that at first seemed like just another blip in the routine collection of data. But it was far from routine. It was something entirely different. Something that would force humanity to confront an entirely new understanding of the universe. The telescope captured a faint streak of light moving rapidly across the sky. It didn't belong. It wasn't part of the predictable cosmic dance of comets, asteroids, or anything we had seen before in our solar system. This object didn't follow the typical elliptical orbit of a comet. It didn't behave like an asteroid. It wasn't bound to our sun's gravity, as all other celestial bodies within our solar system are. It wasn't orbiting the sun, nor was it circling around a planet. This was an object that had traveled from beyond our solar system, passing through space with a speed and trajectory that defied all known laws of physics. The object was later named Oumuamua, which in Hawaiian means scout or messenger from afar. It was a fitting name because in many ways, Oumuamua was a messenger, one that came from a distant corner of the galaxy, bringing with it a series of questions that would change our understanding of space forever. It was the first confirmed interstellar object ever detected passing through our solar system, and its arrival would alter the course of astronomical research for years to come. When astronomers first began analyzing the object's path, the data sent shockwaves through the scientific community. The object was moving at an extraordinary speed, about 87,000 kilometers per hour. While this wasn't entirely unprecedented for objects in the solar system, what was remarkable was its trajectory. Unlike the predictable orbits of asteroids or comets, Oumuamua's path was hyperbolic, meaning it wasn't gravitationally bound to the sun. It was simply passing through on a trajectory that would eventually send it back into deep space, never to return. Its speed, 26 kilometers relative to the sun, was faster than any object we had previously observed in our cosmic neighborhood. The implications were staggering. Interstellar objects like Oumuamua had long been the stuff of science fiction, but now, for the first time, science had a hard, undeniable piece of evidence that the universe was much more dynamic than we had ever believed. We had long thought that Earth was isolated in space, that the vast distances between stars were insurmountable, and that we were alone in our corner of the galaxy. But Oumuamua had shown up as a reminder that, just because we hadn't noticed it before, didn't mean that the cosmos wasn't filled with wanderers passing through our space on journeys from far beyond. Within hours of the object's discovery, astronomers around the world turned their telescopes toward the cosmic visitor, eager to gather as much data as possible before it vanished forever into the blackness of space. The object moved too fast, and the window of observation was too small. Just a few weeks later, it would be too far away for even the most powerful telescopes to track. But as astronomers focused their attention on the object, they were met with an even bigger surprise. Oumuamua wasn't just moving fast, it was accelerating. This was the first clue that something was deeply strange about the object. When comets get close to the sun, the heat causes volatile materials like water to sublimate from the surface, releasing gas and creating a comet's characteristic tail. This outgassing also has the effect of slightly accelerating the object, as the jets of gas push it forward. But Oumuamua showed no signs of a comet's tail. There was no visible outgassing, no water vapor, no organic compounds being released. Yet, despite this, the object was speeding up as it moved away from the sun. This phenomenon baffled astronomers. It was as though some invisible force was pushing the object forward, a force that didn't match any natural explanation. No known comet, asteroid, or even a fragment of a planet could accelerate in this manner, without releasing gases or exhibiting some other sign of propulsion. Oumuamua didn't follow the normal laws of celestial motion, and that left scientists scrambling to figure out what was happening. In the weeks that followed, various theories were proposed to explain the acceleration anomaly. Some scientists suggested that the object was made of an exotic material that responded to solar radiation in ways that were completely unknown to modern science. Others proposed that it might be composed of hydrogen ice, so light and fragile that it sublimated without being detected. But the most radical suggestion came from astronomer Dr. Avi Loeb at Harvard University. He proposed that Oumuamua might be something else entirely, an artificial object, possibly a probe sent by an extraterrestrial civilization. Loeb's theory was controversial, to say the least. Most astronomers dismissed the idea of an alien probe, arguing that the object's strange properties could still be explained by natural causes. But Loeb wasn't the only one to entertain the idea that Oumuamua might not be a natural object at all. The sheer mystery of its behavior, the speed, the trajectory, the unexplained acceleration, suggested that it might have been designed for a purpose beyond what we could comprehend. If it wasn't a natural object, then the possibility that it was artificial couldn't be ruled out entirely. As the scientific community grappled with these questions, the object continued on its journey, speeding away from the sun and out of reach of Earth-based telescopes. By January 2018, it was already too far to observe with the most powerful telescopes on Earth. Its brief but intense appearance in our solar system had left behind more questions than answers, and the object's mystery would linger in the minds of astronomers for years to come. But one thing was clear: Oumuamua was just the beginning. The discovery of this interstellar visitor shattered our long-held assumptions about the isolation of our solar system. It opened up a new realm of possibilities and ignited a new era of space exploration and research. If Oumuamua could travel from another star system, what else was out there drifting through the vast expanse of space unnoticed by human eyes? Until now, the arrival of Oumuamua sparked a revolution in astronomy. It changed the way we looked at the universe, and it changed the way we looked at our place within it. No longer could we assume that Earth was isolated in the vast emptiness between the stars. The universe, it seemed, was much more crowded than we had ever imagined. In the years since Oumuamua's discovery, new technologies have been developed to scan the skies for more interstellar visitors. It became clear that Oumuamua wasn't a one-off. There would be more, many more, and as each new object appeared, it revealed even more mysteries about the nature of the universe and the objects that drift through it. In 2019, just 2 years after the arrival of Oumuamua, a second interstellar object named 2I Borisov was detected. Unlike Oumuamua, 2I Borisov was a typical comet, with a visible tail and signs of outgassing. Yet, its interstellar origin raised similar questions. How often did objects like these pass through our solar system? Were we simply too young in our technological development to have noticed them before? As new telescopes are built and new search algorithms are developed, humanity stands on the cusp of a new understanding of the cosmos. The question is no longer whether we are alone in the universe, it's how many visitors from distant stars are already passing through our cosmic backyard, leaving behind their own strange clues to the secrets of the universe. And perhaps most importantly, the mystery of Oumuamua serves as a reminder. The universe is far stranger, far more dynamic, and far more interconnected than we ever thought possible. We are no longer mere observers of the stars. We are participants in a much larger cosmic drama, one that stretches across billions of years and light years of space. The question now is not if we'll see another interstellar visitor, but when, and what new mysteries they will bring with them. As scientists continue to look to the skies, one thing is certain: the search for answers about the true nature of Oumuamua and its interstellar cousins is only just beginning, and as we continue to discover more about these cosmic wanderers, we may soon come to realize that the universe is far more familiar than we ever imagined. And perhaps we were never really alone in the stars at all. On October 19, 2017, astronomers made a discovery that would go down in history as one of the most important astronomical events of the 21st century. It was an unassuming observation at first. The Pan-STARRS 1 telescope in Hawaii, known for its role in scanning the skies for potential Earth-threatening asteroids and comets, captured a faint point of light, moving rapidly across the sky. At first glance, it appeared to be just another distant object in the vastness of space, but within hours it became clear that this object was unlike anything scientists had ever seen before. It was no ordinary asteroid or comet. It was a cosmic visitor from beyond our solar system. This object, which would later be named Oumuamua, meaning scout or messenger from afar in Hawaiian, was not a part of our solar system, and it wasn't bound by the sun's gravity. In astronomical terms, it was an interstellar object, a visitor from another star system, passing through our solar system on a one-way journey. For the first time in history, humanity was witnessing an object that had come from another part of the galaxy, and it was moving through space at a speed and trajectory that defied conventional understanding. What made Oumuamua even more intriguing was its sheer velocity. Moving at a staggering 87,000 kilometers per hour, it was traveling at a speed far greater than any object observed within our solar system. And not just its speed, the object's path was what truly puzzled scientists. Instead of following a predictable orbit around the sun like comets or asteroids do, Oumuamua followed a hyperbolic trajectory, meaning it was not bound to the sun's gravitational pull at all. It was on a trajectory that would eventually carry it out of our solar system and into the vastness of interstellar space, never to return. This wasn't just a random rock floating through space. It was a cosmic wanderer coming from a distant star system and passing through ours, almost as though it had a purpose. The discovery was a complete game-changer for the world of astronomy. Prior to this event, the idea of interstellar objects originating from outside our solar system was mostly theoretical. While astronomers had speculated that there might be other objects out there drifting between the stars, no one had ever observed one until now. Suddenly, Oumuamua became the center of intense scientific scrutiny and debate, as astronomers around the world scrambled to observe it and understand its origins. As soon as the initial observations were made, astronomers launched an all-out effort to gather as much data as possible before the object passed beyond the reach of Earth's telescopes. But even as the first images of the object were processed, it became clear that Oumuamua was far more than just a random space rock. It was doing things that didn't make sense, things that no one could explain with conventional scientific theories. The first major anomaly that caught astronomers off guard was the object's strange acceleration. As Oumuamua moved away from the sun, it appeared to speed up slightly. Now, this wasn't entirely unheard of. Comets, for example, often experience a slight acceleration as they move away from the sun due to the outgassing of volatile materials like water. But the strange part was that Oumuamua showed no visible signs of outgassing. There was no tail, no visible cloud of gas or dust that typically accompanies comets. In fact, there was nothing about the object that suggested it was behaving like a comet at all. And yet, the data was undeniable. It was accelerating as it moved away from the sun, without any apparent cause. This unexplained acceleration sparked a flurry of theories and speculation. Some scientists initially suggested that the object might be made of a highly reflective material, which could have been pushed by the solar wind. Others proposed that it might be composed of some exotic substance that reacted to solar radiation in ways we didn't yet understand. But none of these theories could fully account for the strange acceleration without introducing some highly unlikely conditions. As time went on, the scientific community found itself grappling with a problem that no one could solve, a mystery that seemed to only deepen the more they studied it. But the acceleration was not the only anomaly that Oumuamua presented. There was something else: its shape. Unlike anything previously observed in our solar system, Oumuamua appeared to be long and elongated, perhaps as much as 10 times longer than it was wide. The object's shape was so strange that it led some researchers to wonder if it might not even be a natural object at all. The object's rapid variation in brightness, up to a factor of 10 over an 8-hour period, further suggested that it wasn't just an ordinary asteroid or comet. It appeared to be rotating, but in a way that no known object in our solar system does. The object seemed to be tumbling end over end, which was entirely different from the typical rotation of asteroids and comets, which usually spin around a central axis. This tumbling motion suggested that Oumuamua might be unstable, or perhaps it had been artificially constructed in a way that we didn't yet understand. Adding fuel to the fire, some scientists began to entertain the possibility that Oumuamua might not be a natural object at all, but rather something engineered. Perhaps it was a probe sent by an extraterrestrial civilization designed to study our solar system or to gather data from far-off regions of the galaxy. This idea, which had been considered pure science fiction, was suddenly on the table. Avi Loeb, a Harvard astronomer, became one of the most vocal proponents of this theory. He suggested that the object's unusual properties, its strange acceleration, its elongated shape, and its behavior might be consistent with the idea of an artificial object, possibly even a light sail, a type of probe that could be propelled by the pressure of starlight. Loeb's hypothesis generated both intrigue and controversy within the scientific community. Many of his colleagues dismissed the idea as far-fetched, but Loeb's argument sparked a broader conversation about the possibility of intelligent life elsewhere in the galaxy and the nature of interstellar exploration. Despite the controversy, the idea of Oumuamua being an alien artifact sparked a renewed interest in the search for extraterrestrial intelligence. If a civilization capable of building such an object existed, then perhaps there were others out there, sending their own probes and messages across the galaxy. For some, the discovery of Oumuamua was a confirmation of their long-held beliefs that we were not alone in the universe, that the galaxy was full of advanced civilizations whose technology was far beyond our own. For others, however, it was a mystery that had yet to be solved, a mystery that could hold the key to understanding the true nature of our universe and our place within it. In the months that followed Oumuamua's discovery, astronomers around the world turned their attention to studying the object as it continued its journey out of the solar system. However, despite the best efforts of scientists, the mystery of Oumuamua remained unsolved. The object's unusual shape and behavior defied explanation, and the data gathered during its brief stay in our solar system raised more questions than answers. The mystery of Oumuamua didn't end when it left our solar system. In fact, its departure marked the beginning of a new era in space exploration. Scientists were left to reconsider the way they thought about space. The idea of interstellar objects coming from beyond our solar system, was no longer a theoretical concept. It was a reality. And with this reality came the realization that we were just beginning to scratch the surface of understanding the true nature of the universe. Since the discovery of Oumuamua, the search for similar objects has intensified. Astronomers have started developing new tools and technologies to scan the skies for interstellar visitors. While Oumuamua was the first known interstellar object, it is likely that it won't be the last. In fact, astronomers are now predicting that similar objects may be passing through our solar system on a regular basis, but we've simply never had the technology to detect them before. As the technology continues to improve, the question is no longer whether we will find another interstellar visitor, but when. And when we do, what new mysteries will it bring with it? The discovery of Oumuamua marked a watershed moment in the history of astronomy. It shattered the assumptions that humanity had about the isolation of Earth and the vastness of space. It showed us that the universe is far more dynamic, far more interconnected, and far more mysterious than we ever thought possible. And while the mystery of Oumuamua may never be fully solved, its arrival has changed the way we view our place in the cosmos. It has sparked a new era of exploration and discovery, one in which the search for answers is only just beginning. As astronomers around the world scrambled to understand the enigmatic interstellar visitor known as Oumuamua, one of the most perplexing aspects of its nature was its shape. It was unlike any asteroid or comet that had ever been observed in our solar system. and its strange features only deepened the mystery surrounding it. The object's elongated, cigar-like appearance was a departure from the roughly spherical shapes typically seen in comets, asteroids, or other celestial bodies in our solar system. In fact, Oumuamua's form was so unconventional that it forced scientists to entertain theories that had never before been considered, including the idea that the object might not be a natural formation at all. One of the first clues to the object's oddity came from its brightness. As it tumbled through space, Oumuamua's brightness varied dramatically, fluctuating by a factor of 10 in a predictable 8-hour cycle. This was unlike anything astronomers had seen in a comet or asteroid. Most asteroids and comets, while they may show some variation in brightness due to their rotation, typically have much smaller fluctuations. The fact that Oumuamua's brightness changed so dramatically indicated that it was rotating in a highly unusual way, possibly end over end, like a giant cosmic disk. This non-principal axis rotation, as astronomers called it, was another strange feature that could not be easily explained by the typical behavior of known space rocks. To understand the significance of this, it's important to know how most celestial objects behave. In the vacuum of space, objects tend to rotate in such a way that their shortest axis is aligned with the axis of rotation, similar to how a top spins on a table. This is the most stable configuration and is the result of countless collisions and gravitational interactions over millions of years. But Oumuamua didn't rotate this way. Instead, it appeared to be tumbling erratically, rotating around an axis that was not its shortest axis, which indicated something had happened to it that was different from other objects in our solar system. Perhaps it had been destabilized by a violent collision or had been subjected to forces that caused it to behave in a way no one had anticipated. But the strange rotation was just the beginning. The object's shape, combined with its erratic rotation, led scientists to propose a number of possible explanations. One theory suggested that Oumuamua was a fragment of a larger object, possibly broken apart by a violent cosmic event, such as a supernova or the destruction of a planet around a distant star. However, there were issues with this theory. Oumuamua was simply too stable, too intact for something that had supposedly been shattered in such an event. Objects that survive supernova or planetary destruction typically exhibit signs of massive damage, fractures, craters, and erosion. Yet, Oumuamua appeared structurally intact, defying the expected consequences of such an event. In the face of these questions, some astronomers began to consider an even more radical theory. What if Oumuamua wasn't a natural object at all? Could it be an artificial artifact, possibly sent by an extraterrestrial civilization? The suggestion seemed outlandish at first, but the more astronomers looked at the data, the more they realized that the object's peculiar characteristics could be interpreted as signs of an artificial origin. For one, its shape. A long, thin cigar was unlike anything seen in nature. While comets and asteroids typically take on a roughly spherical or irregular shape, Oumuamua's highly elongated form appeared to be too perfect, too symmetrical to be the result of random natural processes. Adding to the suspicion was the object's unusual acceleration as it moved away from the sun. As mentioned earlier, comets often speed up as they approach the sun, due to the outgassing of volatile materials like water and carbon dioxide. This gas creates jets that push the comet forward, propelling it on its journey. But Oumuamua showed no such signs of outgassing. There was no visible tail, no cloud of dust or gas, and yet it accelerated as it moved away from the sun. This behavior could be interpreted as evidence that the object was being propelled by something other than the typical forces observed in natural space bodies. Some scientists began to entertain the idea that the object might be a piece of technology designed to travel through space, perhaps even a probe sent on a long journey to explore the galaxy. Dr. Avi Loeb, a Harvard University astronomer, became one of the most vocal proponents of this hypothesis. In his 2021 book, Extraterrestrial, Loeb argued that Oumuamua's strange shape, unusual acceleration, and lack of visible outgassing all pointed to the possibility that it was not a comet or asteroid at all, but rather an artificial object sent by an advanced extraterrestrial civilization. He suggested that Oumuamua might be a type of light sail, a hypothetical technology that would use radiation pressure from a star to propel a thin, flat object across the cosmos. This would explain the object's high velocity and strange motion, as a light sail would accelerate in response to the pressure exerted by sunlight. Loeb's theory was controversial to say the least. The idea of an extraterrestrial object passing through our solar system was something that had long been relegated to the realm of science fiction. Many astronomers were quick to dismiss the notion, arguing that the natural explanations for Oumuamua's behavior, while incomplete, were far more plausible than the idea that it was an alien probe. They pointed to the object's lack of detectable outgassing as evidence that it wasn't a comet, but suggested that it could still be a fragment of a comet or asteroid ejected from a distant star system. Others speculated that the object might be composed of exotic materials that caused it to behave in strange ways, or that its peculiar shape was the result of gravitational forces acting on it as it passed through interstellar space. Despite the skepticism from many of his colleagues, Loeb's ideas sparked a broader discussion about the possibility of extraterrestrial life and the potential for intelligent civilizations to communicate with us in ways we don't yet understand. If Oumuamua was indeed an artificial object, it would be the first direct evidence of intelligent life beyond Earth, something that would fundamentally change our place in the universe. Even if the object wasn't a probe, its bizarre behavior and origin raised profound questions about the nature of the universe and the possibility that other civilizations might exist in the vast expanse of space. As the debate over the object's origin raged on, astronomers around the world continued to study Oumuamua, gathering what data they could before it faded into the distance. But despite the efforts of the scientific community, the object's mysteries remained largely unsolved. No one knew for sure where it had come from, why it moved the way it did, or what it was made of. Yet the discovery of Oumuamua had already had a profound impact on the field of astronomy. It had forced scientists to rethink their assumptions about the universe and the nature of interstellar objects, and it had ignited a renewed interest in the search for extraterrestrial life, with many researchers now exploring the possibility that the object could be a sign of something much greater, a glimpse into the unknown. What we do know is that Oumuamua's arrival marked the beginning of a new chapter in humanity's understanding of the cosmos. It shattered the assumptions we had about the isolation of our solar system and opened the door to a new era of exploration and discovery. As scientists continue to look for more interstellar visitors, Oumuamua will remain a symbol of the vastness of the universe and the mysteries that still await us. Whether it was a natural object or an extraterrestrial probe, its legacy will continue to inspire the search for answers to questions that have long eluded humanity. The universe, it seems, has more to reveal than we ever could have imagined. As Oumuamua continued its rapid journey through our solar system and eventually disappeared from the reach of our telescopes, it left behind a trail of confusion, speculation, and wonder. The scientific community, having spent just a few brief weeks studying the interstellar visitor, found itself grappling with questions that had never before been posed. But as the object moved farther away, its mysterious behavior had sparked more than just academic debates. It had also opened the floodgates for future exploration of the unknown, pushing the boundaries of what humanity thought was possible in the realms of space, time, and technology. The questions surrounding Oumuamua's strange trajectory, acceleration, and bizarre shape were only the beginning of a much larger cosmic mystery, one that would shape the next era of astronomical research. In the wake of Oumuamua's departure, astronomers began to think more seriously about the implications of its visit. The more they considered its characteristics, the more they realized that it might not be an isolated phenomenon. Rather, the object could be part of a much larger population of interstellar objects, wanderers from distant star systems that had been passing through our solar system without our knowledge for eons. For decades, humanity had considered the space between stars to be an empty, vast void. Now, thanks to Oumuamua, that perception was being challenged. Perhaps the space between stars wasn't as empty as we had assumed. Perhaps it was a cosmic highway, traveled by wanderers from other parts of the galaxy. In response to the mystery surrounding Oumuamua, astronomers around the world immediately turned their attention to the search for similar objects. There had been no previous effort to track interstellar objects, and the technology for detecting them simply hadn't existed. In fact, prior to Oumuamua, astronomers had never considered the possibility that objects could be passing through our solar system from other star systems. But now, with the possibility of more Oumuamua-like objects existing out there, the search was on in earnest, and it was becoming clear that this was not a one-off event. Oumuamua had opened the floodgates for a new era of astronomical discovery, and the idea that we were part of a much larger cosmic system was no longer just a theory, it was becoming a reality. For years, astronomers had been focused on studying objects within our solar system, comets, asteroids, and other bodies that orbited the Sun. But as soon as Oumuamua arrived, it became clear that this was no ordinary space rock. This was something new, something beyond the confines of our solar system. And as Oumuamua moved farther from the Sun, The scientific community raced to study it, collecting as much data as they could before it slipped beyond the reach of Earth-based telescopes. Observations came in from across the world, new data points, new measurements, new images that painted a picture of an object unlike anything seen before. But as the object grew more distant, the questions only multiplied. What did Oumuamua's presence mean for the future of space exploration? A few years after Oumuamua's departure, astronomers were still processing the data collected from its brief but unforgettable visit. Many scientists felt that the interstellar object could be the first of many more to come. In fact, the discovery of Oumuamua marked a turning point in the way astronomers approached space observation. No longer could they assume that objects from other star systems were simply too distant or too rare to detect. The door to a new frontier had been opened, and if Oumuamua was any indication, the interstellar space between stars was far more crowded than anyone had ever imagined. New surveys and telescopes were rapidly being developed to detect and study more interstellar visitors. One of the most significant projects that emerged was the launch of dedicated sky surveys designed to track interstellar objects and identify those that were traveling through our solar system. Advances in astronomical technology made it possible to detect objects in real time, alerting scientists to their presence before they passed too far to study. One such program was the Pan-STARRS-1 telescope, which had been responsible for the initial discovery of Oumuamua. But astronomers knew that they needed more than just a single telescope to track the growing number of potential interstellar objects. They needed a global network of observatories that could work together to monitor space with unprecedented precision. A new kind of astronomical survey was born. These surveys were designed to detect objects that weren't just from our solar system, but from beyond the stars. They would identify hyperbolic trajectories, those that indicated objects had entered the solar system from other star systems. Such objects would be the key to understanding more about the structure of the galaxy and the movement of material between stars. And Oumuamua had given astronomers a glimpse of just how much there was to discover. It wasn't just about spotting strange objects, it was about reshaping our understanding of space itself. The scientific community was reeling from the implications of this new paradigm. In 2019, a second interstellar object, known as 2I was discovered, further confirming that Oumuamua was not an anomaly. It wasn't a one-off object that had been sent by an alien civilization or a freak occurrence. It was part of a larger, ongoing flow of material traveling between stars, and this in turn posed a larger question. If Oumuamua and 2I were just the beginning, then how many more such objects were out there, drifting through space without our knowledge? How many others had passed by Earth undetected, lost to the vastness of space before we had the technology to notice them? Astronomers were learning that they had only scratched the surface of a much larger cosmic system. Objects like Oumuamua were not rare outliers. They were potentially a regular feature of space. Just as comets and asteroids populated the solar system, interstellar objects might be a common occurrence. But until the development of the right tools and techniques, these objects had gone unnoticed, passing through our solar system without so much as a second glance. Now the floodgates were opening, and the world of astronomy was being forced to confront a vastly larger and more complex universe than it had ever imagined. The implications for space exploration were profound. If interstellar objects were common, this meant that humanity's search for life and knowledge in the cosmos needed to be expanded. The focus would no longer be solely on finding planets or moons that might harbor life, but on tracking and understanding these wandering cosmic visitors. As scientists began to speculate on the origins of these objects, they realized that the very fabric of the galaxy was far more interconnected than anyone had assumed. Stars weren't isolated islands in a vast ocean of space. They were part of a larger galactic ecosystem, with material, whether organic compounds, comets, or fragments of planets, flowing constantly from one star system to another. The growing realization that the space between stars wasn't empty led to a fundamental shift in how we think about the universe. For centuries, the idea that we were alone in a corner of space, isolated from the rest of the galaxy, had shaped humanity's understanding of its place in the cosmos. But now, with the discovery of Oumuamua and its interstellar companions, the idea of isolation was being replaced by one of interconnectedness. We were not just a tiny planet orbiting a single star. We were participants in a vast galactic network of material exchange, with cosmic debris and objects from distant star systems passing through our solar system on a regular basis. And if these objects could travel through space, carrying with them chemical signatures and clues about other worlds, then what else might be out there waiting for us to find it? This was the new frontier of space exploration, a frontier that would continue to evolve and expand as new discoveries were made. The question of whether we are alone in the universe was no longer theoretical. The universe had already started delivering answers, but the journey to understanding had only just begun. With each new interstellar visitor, humanity would move one step closer to comprehending the true scale of the cosmos and the role we play within it. The age of interstellar archaeology had begun, and the search for answers would redefine humanity's future in space. The story of interstellar visitors didn't end with the departure of Oumuamua from our solar system. The unexpected arrival of the object had already forced humanity to rethink its understanding of the universe, and as time passed, it became clear that the implications of that single discovery were far more profound than anyone had initially imagined. It wasn't just a strange cosmic anomaly, it was a harbinger of things to come, suggesting that Oumuamua was not a rare, isolated phenomenon, but the first of many interstellar objects that would eventually pass through our solar system, perhaps more regularly than we ever anticipated. But as with all groundbreaking discoveries, Oumuamua raised more questions than it answered, and it was only in the wake of its departure that astronomers began to understand just how much their field would change in the years to come. The first major realization was that Oumuamua had forced astronomers to confront a previously overlooked aspect of the cosmos, the potential for interstellar objects to visit our solar system. Before Oumuamua, the idea of interstellar objects, rocks, comets, or other cosmic debris from distant star systems was purely speculative. No one had ever observed an object passing through our solar system from outside the bounds of our sun's gravitational influence. The odds of encountering such an object seemed astronomically small, but when Oumuamua arrived, moving at speeds and on trajectories that defied expectations, that notion was shattered. In the years following its discovery, astronomers began to reconsider their calculations. The data from Oumuamua suggested that objects like it could be far more common than previously thought. If one interstellar object could slip through our solar system, what was stopping others from doing the same? The problem was, for decades the tools and methods used to observe the sky had been focused almost exclusively on objects within our own solar system. Comets, asteroids, and other debris that orbited the sun had been the primary subjects of study. But now that astronomers knew that interstellar objects were out there, the question became, how many had we missed? How many had already passed by Earth without us even knowing they were there? This realization spurred an entire new field of study, interstellar object detection. Astronomers knew that they had to be more proactive in identifying potential interstellar visitors. After Oumuamua, the urgency to detect other objects like it grew, but doing so wasn't easy. Interstellar objects are by their very nature fleeting, coming into the solar system from random directions and quickly moving away. They don't stick around long enough for astronomers to gather detailed data, and they tend to be much harder to spot than the objects that belong to our solar system. These interstellar visitors are often small, faint, and far less predictable than the comets and asteroids that populate our solar system. The next major breakthrough in the search for interstellar objects came in 2019, when astronomers detected the second confirmed interstellar visitor, 2IATLAS Borisov. Unlike Oumuamua, which had defied all expectations in terms of shape and behavior, 2IATLAS Borisov was much more in line with the characteristics of a typical comet. It had a visible tail, exhibited signs of outgassing, and behaved much like the comets we see regularly within our solar system. However, what made 2IATLAS Borisov particularly significant was the fact that it had come from another star system. This discovery solidified the idea that Oumuamua wasn't a one-off event. It was evidence that interstellar objects could and likely would be detected with increasing frequency as our technology improved. The arrival of 2IATLAS Borisov marked a shift in how the astronomical community approached the study of these objects. No longer was it a question of if there were more interstellar objects out there. It became a question of how many and how often they would be encountered. The unexpected nature of these objects meant that astronomers had to quickly adjust their priorities. Survey programs, which had been focused largely on cataloguing objects within our solar system, now had to include interstellar objects in their scope. New algorithms were developed to detect objects traveling at hyperbolic trajectories, and telescopes around the world were reassigned to monitor the skies more closely for similar visitors. This rapid shift in focus was driven by the understanding that the detection of interstellar objects was no longer a matter of theoretical curiosity. The arrival of 2IATLAS had proven that our solar system wasn't a static, isolated point in the galaxy. We were, in fact, part of a vast galactic network, where material from distant stars could be exchanged freely. And if these interstellar objects could travel across the galaxy, perhaps they carried with them clues about the conditions that shaped their parent star systems. If comets and asteroids were the building blocks of planets and moons in our solar system, what could these interstellar visitors tell us about other stars? What might we learn from the fragments of planets, debris, or even the chemical signatures of distant worlds? The discoveries of Oumuamua and 2I had profound implications for the study of astrobiology. If interstellar objects were frequent visitors to our solar system, it raised the possibility that they could carry with them not just material, but perhaps even organic compounds or the building blocks of life itself. The theory of panspermia, the idea that life might be spread across the galaxy by cosmic debris, had long been a subject of scientific speculation. But now, with the discovery of interstellar objects, the idea of life traveling between star systems was no longer just a hypothesis. The possibility that biological material could hitch a ride on a comet or asteroid, crossing the vast distances between stars, seemed more plausible than ever before. The implications of these discoveries also extended to the search for extraterrestrial intelligence, SETI. If intelligent civilizations existed elsewhere in the galaxy, it was possible that they might be sending physical objects, probes, or even messages in the form of interstellar debris. Oumuamua had already sparked discussions about the possibility that it might be an artificial object, possibly a probe sent by an alien civilization. While most scientists dismissed this idea, the fact that Oumuamua had exhibited so many strange behaviors left the door open for further speculation. If the universe was teeming with intelligent civilizations, it was possible that some of them had figured out how to send their technology across vast distances in space, in the form of objects like Oumuamua or 2I. As the detection of interstellar objects became more routine, the question of whether these objects were natural or artificial would become an increasingly important area of study. In the years since the discoveries of Oumuamua and 2I, the field of interstellar object research has only continued to grow. The scientific community has made it a priority to build better detection tools, develop more sophisticated algorithms, and create an international network of observatories capable of tracking interstellar objects. The hope is that, with the right tools in place, astronomers will be able to identify future interstellar visitors earlier in their journey, giving them more time to study these objects before they pass beyond the reach of Earth-based telescopes. Already, astronomers are preparing for the next major discovery, the Vera C. Rubin Observatory, a state-of-the-art facility under construction in Chile, will be one of the most important instruments for the detection of interstellar objects in the years to come. Once operational, the observatory will be capable of scanning the entire sky every few nights, searching for objects on hyperbolic trajectories that might be interstellar in origin. The observatory's advanced technology will provide astronomers with a much more detailed view of the skies, allowing them to track and analyze interstellar objects with unprecedented precision. In the near future, we may even see missions designed specifically to intercept interstellar objects. Space agencies such as NASA and the European Space Agency are already considering the possibility of launching probes to study these visitors up close. While the idea of sending a spacecraft to intercept an interstellar object might seem like science fiction, the technology is slowly moving toward making such missions possible. And if an interstellar object is detected at just the right time, scientists may one day be able to launch a probe that will travel alongside it, gathering data about its composition, origins, and behavior. As humanity moves further into the age of space exploration, the study of interstellar objects will be a key area of focus. These objects are the messengers of the galaxy, carrying with them the history of distant star systems and the secrets of the universe. Their study will offer us a glimpse into the broader processes that shape the cosmos, and perhaps even reveal the truth about our place in the universe. Whether these objects are fragments of other worlds or remnants of ancient cosmic events, they offer a window into the unknown, and the discoveries yet to come could be as profound as anything we've learned so far. In the years ahead, we will continue to explore the mysteries of the cosmos, and as we do, we will be guided by the legacy of Oumuamua and 2I. These interstellar wanderers have already changed the way we think about the universe, and as we learn more about them, they will continue to inspire a new generation of scientists, explorers and thinkers to look beyond the stars, to understand the deep, interconnected nature of the galaxy, and to search for the answers to questions that have long eluded us. The universe, it seems, is not as empty as we once thought, and with each new discovery we are reminded just how vast, mysterious, and interconnected our existence truly is. As the dust began to settle after the discovery of Oumuamua, and the confirmation that interstellar objects could indeed make their way through our solar system, the scientific community found itself in an entirely new realm of possibilities. The implications of these discoveries extended far beyond the technical aspects of astronomical observation. They forced humanity to confront fundamental questions about our place in the universe, the nature of life itself, and whether or not we are truly alone in the cosmos. The revelation that interstellar objects could travel through space, bypassing the gravitational pull of our sun, was as profound as it was bewildering. These objects, coming from distant star systems, carried with them information not only about the conditions of their home systems, but also about the larger structure of the galaxy itself. For centuries, scientists had thought of our solar system as relatively isolated, with the sun's gravity keeping everything contained within its orbit. The discovery that objects like Oumuamua could arrive from far beyond the solar system changed that view dramatically. Suddenly, the galaxy seemed less like a collection of isolated star systems and more like a vast, interconnected network, with material traveling freely between stars. This realization had profound implications for the way we think about life in the universe. If objects like Oumuamua and 2I Borisov traveling through space for millions, if not billions of years, could reach our solar system, could the same thing happen with life? The theory of panspermia, which suggests that life could be spread throughout the galaxy by space debris, had long been speculative, but with the discovery of interstellar objects, that theory gained new traction. Could life or the building blocks of life be transported from one star system to another, riding on comets, asteroids, or fragments of planets? The possibility of panspermia has intrigued scientists for decades. The idea that life on Earth could have originated from another star system is both thrilling and humbling. It suggests that life might not be a rare anomaly, but rather a common feature of the universe. If life can be transported across vast distances, it implies that life could exist in countless other places throughout the galaxy, perhaps even throughout the entire universe. The discovery of interstellar objects only strengthened the idea that life might be far more widespread than we've ever imagined. If material from other star systems can travel through space, it raises the question, is it possible that life itself could be carried by these objects? Could microorganisms have survived the harsh conditions of space, traveling from one star system to another, potentially seeding new worlds with life? These questions are not just academic, they have deep philosophical and existential significance. For centuries, humanity has grappled with the idea that we might be the only intelligent beings in the universe. The search for extraterrestrial life has driven much of modern scientific exploration. The discovery of interstellar objects like Oumuamua and 2I Borisov, while not direct evidence of extraterrestrial life, offered a tantalizing glimpse into the possibility that life might be far more common than we ever imagined. And while the notion of life being carried between star systems is exciting, it also presents significant challenges. If life is to be transported across the vast expanse of space, it would have to survive the rigors of the interstellar journey. The conditions in space are harsh, temperatures near absolute zero, exposure to intense radiation, and the vacuum of space itself. Yet some microorganisms on Earth are known to be remarkably resilient, capable of surviving in extreme environments. Scientists have even discovered life forms living in the most inhospitable places on Earth, such as deep under the ocean or in acidic environments. This resilience raises the possibility that life could indeed survive the journey through space, transported by comets or asteroids, potentially arriving at distant planets in other star systems. While the idea of life traveling between stars is still speculative, the discovery of interstellar objects has changed the way we approach the search for extraterrestrial life. The idea that life could be distributed throughout the galaxy, carried by objects passing through space, means that we should not limit our search to specific planets or moons. Instead, we might need to consider that life could exist on distant worlds, but that it arrived there not through traditional means, like evolution within a single ecosystem, but via a much more complex and far-reaching process of material exchange. This idea could shift the focus of astrobiology research, making it more about tracing the paths of interstellar material and understanding how life could spread across the galaxy, rather than focusing solely on finding habitable planets within a narrow Goldilocks zone. At the same time, the question of whether we are truly alone in the universe has taken on new urgency. For much of human history, we've looked to the stars and wondered if other civilizations existed out there. The discovery of interstellar objects like Oumuamua sparked speculation about the possibility that these objects might not just be natural debris, but something more, perhaps even probes or artifacts from intelligent extraterrestrial civilizations. The unusual characteristics of Oumuamua, its strange acceleration, its cigar-like shape, and its unpredictable rotation led some scientists like Dr. Avi Loeb to propose that it could be an artificial object. Loeb suggested that the object might be a probe sent by an advanced civilization, traveling through space on a mission to explore or gather data. While most scientists rejected the idea of Oumuamua being an artificial object, the very fact that the question was raised signaled a shift in how we think about extraterrestrial life. If interstellar objects could be artificial, then it raises the possibility that intelligent civilizations might exist elsewhere in the galaxy, sending probes or signals to explore the cosmos. The discovery of Oumuamua, whether or not it is an artificial object, has pushed the search for extraterrestrial intelligence SETI into new realms. It has shown us that the galaxy is not just a place where life could potentially arise, but that it could already be teeming with intelligent civilizations, sending probes, signals, or even messages that we might not yet be able to detect. The question of whether we are alone in the universe is no longer simply a matter of searching for planets with the right conditions for life. It is now about searching for the signs of civilizations that might already be out there. But as humanity stands on the brink of this new era in space exploration, it is important to acknowledge the limitations of our current understanding. While the discovery of interstellar objects has sparked immense excitement, the truth is that we are still in the early stages of understanding the true nature of these cosmic wanderers. We know that Oumuamua and 3IATLAS came from other star systems, but beyond that, much remains a mystery. What are their origins? How are they formed? And what does their presence in our solar system tell us about the broader dynamics of the galaxy? As scientists continue to study these objects, they will learn more about their composition, their behavior, and their trajectories. The study of interstellar objects has the potential to reveal fundamental truths about the structure of the galaxy, the processes that shape planetary systems, and the history of our own solar system. But perhaps more importantly, it offers us a chance to rethink our place in the universe. The discovery of these objects suggests that the universe is far more interconnected and dynamic than we ever imagined. Our solar system is not isolated. It is a part of a vast interconnected network of stars, with material constantly flowing between them. The implications of this discovery are not just scientific, they are philosophical and existential as well. If life and material can travel across the galaxy, then it challenges our understanding of what is truly unique about our own existence. We are not isolated in a quiet corner of the universe, but instead we are part of a much larger cosmic system, one that is constantly evolving and exchanging material across vast distances. The discovery of interstellar objects has forced humanity to reconsider its place in the cosmos. We are no longer simply observers of the universe, but participants in a much larger galactic drama. And as we continue to explore the mysteries of these objects, we may come to realize that we are not alone in the galaxy, and perhaps never have been. In the end, the discovery of Oumuamua and other interstellar visitors has opened up new possibilities for science, exploration, and our understanding of life in the universe. As we continue to study these objects and search for more, we will uncover secrets that could change the course of human history. Whether or not we find proof of extraterrestrial life, the journey will be one of discovery, wonder, and perhaps even revelation. The universe is far stranger, more interconnected, and more mysterious than we ever imagined. And as we explore its depths, we may find that the answers to our deepest questions have been out there all along, waiting to be discovered. As humanity embarks on its quest to understand the vastness of the cosmos, the question of how we connect to the larger universe has become ever more pressing. With the arrival of Oumuamua in 2017, followed by 3IATLAS and other potential interstellar objects, the barriers between Earth and the far reaches of space began to blur. These objects traveling across the galaxy and entering our solar system from beyond the realm of our sun's influence have not only expanded our view of the universe, but have also forced us to reconsider the fundamental assumptions we've held about life, intelligence, and the possibilities of cosmic interconnectedness. In the years since these groundbreaking discoveries, a deeper question has emerged. If interstellar objects like Oumuamua and 3IATLAS are so common, what else could be out there? As astronomers refine their methods for tracking interstellar visitors, and as new telescopes and missions are launched to gather more data, The possibility of more frequent encounters with these cosmic wanderers has become a central focus of space exploration. But this isn't just about observing strange objects. It's about preparing for a future where humanity might eventually encounter something even more extraordinary. The discovery of Oumuamua, in particular, ignited widespread speculation about the possibility that the object wasn't merely a natural fragment of a distant star system, but something engineered, perhaps an alien probe or an artifact sent by a civilization from another world. The idea of alien technology or intelligence being involved wasn't just the stuff of science fiction. It became a legitimate avenue of discussion within the scientific community. If Oumuamua wasn't a random space rock, then what did it mean for our understanding of life beyond Earth? Could this be the first tangible evidence of extraterrestrial life or technology? Though the theory of Oumuamua being artificial remained speculative, it nonetheless raised the prospect that there could be other civilizations out there, sending objects across the vast distances of space. If intelligent beings exist elsewhere in the galaxy, they may have already established methods for communicating or exploring the cosmos in ways that we are only beginning to understand. And as more interstellar objects are detected and studied, the question of whether they are natural or artificial will likely become a central focus of scientific inquiry. But the search for extraterrestrial life, whether in the form of intelligent probes or microorganisms, is just one facet of the broader scientific exploration sparked by these interstellar objects. The real breakthrough that Oumuamua and 2I Borisov have provided is the recognition that our solar system is not isolated. We have always assumed that Earth exists in a remote corner of the galaxy, separated from other star systems by vast stretches of empty space. But now we know that material from comets and asteroids to larger bodies moves freely between stars. This realization has reshaped our understanding of cosmic dynamics, highlighting the interconnectedness of the galaxy and challenging the long-held notion that our solar system is a lonely outpost in the universe. The detection of these interstellar objects has begun to redefine how we think about the neighborhood around our solar system. For most of human history, we have regarded the space between stars as an empty void, but the arrival of Oumuamua and Borisov suggests that the galaxy is far more crowded than we previously believed. It's no longer accurate to describe the space between stars as a lifeless, empty expanse. In fact, it could be teeming with cosmic debris, wandering objects, and even potential carriers of life. This has profound implications not just for the way we study space, but for how we perceive our place in the cosmos. Given the frequency with which objects like Oumuamua and 2I Borisov are now being detected, it's clear that interstellar travel, at least for objects, is a far more common occurrence than we had once thought. For years, scientists have theorized that material from other star systems might occasionally make its way into our solar system, but we lacked the observational tools to detect such objects. Now that the technology exists to identify them, we realize that interstellar material is moving through our solar system on a regular basis, though we may not always be able to see it until it's already passed by. This new understanding opens up exciting avenues for future exploration. As we continue to improve our telescopes, space observatories, and data analysis methods, the detection of interstellar objects will only become more routine. The next generation of telescopes, such as the James Webb Space Telescope, JWST, and the Vera C. Rubin Observatory, will provide unprecedented resolution and sensitivity, allowing astronomers to monitor the skies for these wandering objects with a level of detail never before possible. With such tools at our disposal, the question is no longer whether we'll discover more interstellar visitors, but how soon they'll arrive and what we'll learn from them. In fact, as we prepare for future encounters with interstellar objects, there is the possibility of more ambitious missions that could allow us to study them up close. Space agencies like NASA and the European Space Agency, ESA, have already begun discussing the potential of intercepting and studying these visitors. The idea of sending spacecraft to study interstellar objects is still in its infancy, but it could become a reality within the next few decades. A probe designed to visit an interstellar object would have to be capable of traveling long distances and enduring the harsh conditions of space. But as space exploration technology continues to improve, such missions could become more feasible. These missions would allow scientists to analyze the composition, structure, and even the potential for life-bearing material aboard these objects. One key question that continues to arise in the wake of Oumuamua's discovery is whether interstellar objects could harbor organic material or even the building blocks of life. As mentioned, the theory of panspermia has gained renewed interest as a result of these discoveries. The idea that life, or at least the precursors to life, could be transported across the galaxy on comets, asteroids, or other space debris is both exciting and daunting. Could it be that our own planet's earliest life forms were seeded by material arriving from another star system? While we don't yet have conclusive evidence to support this idea, the discovery of interstellar objects suggests that the possibility should be taken seriously. The connection between the study of interstellar objects and astrobiology is only beginning to unfold. If future objects are found to contain organic compounds or biological material, it would drastically shift our understanding of the origins of life. Rather than being confined to one star system, life could potentially be distributed across vast expanses of space, carried by these interstellar objects. The implications for the search for extraterrestrial life would be profound, suggesting that life in the universe is not limited to a handful of planets in a narrow habitable zone, but could be widespread throughout the galaxy. But perhaps the most important revelation in the wake of the discovery of these interstellar objects is the growing understanding that we are not alone in the universe. For centuries, humanity has struggled with the question of whether we are the only intelligent beings in the cosmos. The discovery of Oumuamua and other interstellar objects forces us to consider that the galaxy is not a silent, empty expanse, but a dynamic, interconnected space where material from dust particles to potential probes travels freely between stars. If we are to take this new reality seriously, it suggests that intelligent civilizations could exist far beyond our solar system, sending their own probes, messages, or even artifacts into space. While we cannot say with certainty whether Oumuamua or other interstellar objects are of extraterrestrial origin, the fact that they exist at all forces us to re-evaluate the nature of life in the galaxy. The search for extraterrestrial intelligence, long confined to the search for radio signals or alien megastructures, may now extend to the study of physical objects, spacecraft, artifacts, or probes that may have traveled across vast distances to reach us. As the study of interstellar objects progresses, it's clear that we are on the cusp of a new era in space exploration. The discoveries of the past few years have already begun to reshape our understanding of the universe, pushing the boundaries of what we thought was possible. These objects are not just visitors to our solar system, they are messengers from other worlds, carrying with them clues about the conditions and processes that shape star systems and planetary bodies. And perhaps in the future they will carry something even more profound, a message from another civilization, a sign that we are not alone in the universe. In the end, the discovery of interstellar objects is not just a scientific achievement, it is a philosophical one. It challenges us to rethink our place in the cosmos, to reconsider the nature of life, intelligence, and our own existence. The universe is far more interconnected, dynamic, and mysterious than we ever imagined. And as we continue to study these objects, we will be drawn deeper into the cosmic drama that is unfolding all around us. The discovery of interstellar objects, particularly with the unexpected arrival of Oumuamua in 2017, has sparked a dramatic shift in how scientists perceive the structure of the cosmos and humanity's place within it. What began as a fascinating but puzzling anomaly has turned into one of the most profound developments in modern astronomy, one that will likely shape the future of space exploration and our understanding of the universe for decades to come. But as with all scientific breakthroughs, the initial excitement has been followed by a steady deepening of questions, a growing recognition that Oumuamua may not have been an isolated event, but the beginning of a new chapter in our understanding of the universe. While the world marveled at the unusual shape, speed, and behavior of Oumuamua, it was the deeper implications of its passage that have kept scientists and astronomers busy. The discovery didn't just point to the existence of interstellar objects, it raised larger questions about the nature of the universe and our place within it. If objects like Oumuamua can travel across such vast distances, what else is out there? How does our solar system fit into the broader architecture of the galaxy? Are we truly alone? Or are these objects telling us something more profound about the potential for life and intelligence in the cosmos? The questions that arose in the wake of Oumuamua's passage have only multiplied, and astronomers are only beginning to scratch the surface of what might lie ahead. The implications of interstellar objects are vast, and they go beyond just the study of space debris or the search for extraterrestrial life. For centuries, the universe has been viewed as a vast, dark expanse, with stars scattered across the sky, and planets orbiting in predictable patterns around them. For the most part, our understanding of the cosmos has been shaped by the limits of our perception. We've looked out into the sky, tried to identify the objects that pass through it, and made assumptions about the relationships between the stars and planets. But the discovery of Oumuamua and other interstellar visitors has begun to upend that worldview. These objects are not just passing through our solar system, they are part of a larger cosmic network, one that is constantly exchanging material across light years of space. In many ways, Oumuamua was a cosmic messenger, bringing with it a message that humanity had been waiting for, even if we didn't fully understand it at the time. It was a clue that our solar system is not isolated, but connected to a much larger dynamic system that stretches across the galaxy. And it was a reminder that we are not just observers of the universe, but active participants in it, capable of discovering things that will continue to change the way we perceive the cosmos. As Oumuamua's presence faded into the vastness of space, astronomers were left to wonder, if this object could travel across interstellar distances, then how many more are out there, and what other discoveries might await us as we look deeper into the galaxy? With the discovery of Oumuamua, the concept of interstellar travel once reserved for science fiction was suddenly thrust into the realm of possibility. While many scientists were initially skeptical about the idea that Oumuamua was anything other than a natural object, the data it provided opened new doors for discussion. Its unusual trajectory, speed, and lack of visible outgassing suggested that it was unlike any comet or asteroid we had ever observed. Could this be a sign of an advanced civilization sending a probe across the vast stretches of space? Or perhaps Oumuamua was simply a fragment of a much larger cosmic event, an asteroid, a fragment of a planet, or even the remnant of a shattered star. While the idea of it being a deliberate probe remains speculative, the fact that such a strange object could exist in the first place has changed the way we think about the universe. The next major step in the study of interstellar objects came in 2019, when astronomers detected a second object from beyond our solar system, named 2I Borisov. Unlike Oumuamua, which displayed unusual behavior that led to the hypothesis of artificial origins, 2I Borisov was a more typical comet. However, its interstellar origin was confirmed, further proving that Oumuamua wasn't a fluke. If two such objects had already passed through our solar system, could there be more out there waiting to be discovered? And if these objects are so common, how much more is there to learn about the materials that drift between stars? Interstellar objects like Oumuamua and 2I Borisov are not just random cosmic travelers. They are pieces of the puzzle that reveal the larger structure of the galaxy. They challenge the traditional notion of the solar system as a self-contained system, isolated from the rest of the galaxy. These objects provide a direct link between the stars, a connection that humans have only begun to understand. The discovery of such objects suggests that the space between stars may not be as empty as we once thought. In fact, it may be filled with material dust, gas, rocks, and perhaps even biological material that constantly drifts from one star system to another. The implications for our understanding of the galaxy are profound. The universe is not just a collection of isolated star systems, it is a vast, interconnected network with material flowing freely between stars and solar systems, possibly even carrying life and information across vast distances. One of the key questions that has emerged from the study of interstellar objects is whether these objects could carry the building blocks of life. The theory of panspermia, which suggests that life could be spread throughout the galaxy by comets and asteroids, has been around for centuries, but the discovery of interstellar objects has given this theory new life. If material from distant star systems can travel across the vast reaches of space, could it carry with it the chemical building blocks of life? Could life, or at least the precursors to life, be transported from one star system to another, potentially seeding new planets with the raw materials for life to emerge? While the evidence for panspermia is still speculative, the possibility that life could spread between stars through the movement of interstellar material has significant implications for the search for extraterrestrial life. If life can travel across space on comets or asteroids, it means that the conditions for life may not be as rare as we once thought. It could mean that life exists in countless other star systems, perhaps thriving on distant planets or moons. And it could mean that life itself is not bound by the limitations of a single planet or star system, but can move freely across the galaxy, taking root wherever conditions are right. The discovery of interstellar objects has made this idea seem far more plausible, and it has raised new questions about the nature of life in the universe. The study of interstellar objects is not just about looking for life, though. It is about understanding the fundamental processes that shape the galaxy. These objects are relics of distant star systems, and they carry with them information about the conditions that existed in those systems. By studying their composition, astronomers can learn more about the chemical makeup of other star systems, the processes that govern planetary formation, and the history of the galaxy itself. Interstellar objects are like cosmic time capsules, providing a snapshot of the universe from a distant perspective. They are a glimpse into the distant past of other stars, and a key to understanding the forces that have shaped the galaxy over billions of years. As the study of interstellar objects progresses, it will undoubtedly lead to new insights and discoveries that challenge our understanding of the universe. These objects offer a direct connection between the stars, a reminder that we are part of a much larger cosmic system. The galaxy is not a collection of isolated islands, each star and planet separated by vast distances. It is a network of material, energy and information that flows freely between stars, connecting us all in ways we are only beginning to understand. The arrival of Oumuamua was a wake-up call, a reminder that the universe is far more dynamic and interconnected than we have ever imagined. As more interstellar objects are discovered, we will be faced with new challenges and new opportunities to expand our understanding of the cosmos. And as we look to the future, we must ask ourselves, how will humanity respond to these discoveries? Will we continue to search for the answers to the questions they raise, pushing the boundaries of space exploration and scientific inquiry, or will we remain content with the knowledge we have, limited by the walls of our solar system? The discovery of Oumuamua and other interstellar objects has opened up a new frontier in space exploration. It has challenged our assumptions about the universe, and it has shown us that we are not alone in the galaxy. The universe is full of cosmic travelers, and perhaps someday we will be able to join them on their journey. But for now, we are left with the awe-inspiring knowledge that the universe is far larger, more interconnected, and more mysterious than we ever could have imagined. And as we continue to explore the unknown, we may just discover that the answers we seek have been waiting for us all along. As astronomers, scientists, and even the general public continue to absorb the profound implications of discovering interstellar objects like Oumuamua and 2I Borisov, the question becomes, what's next for the study of these cosmic wanderers? These discoveries, seemingly isolated and strange at first, have ignited an entirely new direction for space exploration, one that promises to fundamentally change how we view the universe. The reality is that interstellar objects like these are likely not anomalies at all, but rather examples of a larger, still mostly unexplored phenomenon. With advances in technology, refined methodologies, and global collaboration, the next generation of astronomers and space explorers will undoubtedly make new discoveries that will continue to reshape our understanding of the galaxy. The first question that arises from this ongoing investigation is how many more interstellar objects remain undiscovered. As scientists have pointed out, Oumuamua wasn't detected until it was already well on its way out of our solar system. This speaks to a larger issue. How do we spot these objects while they are still within our reach? The brief window in which we are able to observe these interstellar visitors is crucial for collecting data. With each missed opportunity, we lose valuable information about where these objects come from, what they are made of, and what they can tell us about the broader cosmic environment. And as researchers quickly learned, this window is not just a few days or weeks, it's much shorter than initially expected. Most of these objects move through the solar system at incredible speeds, and unless astronomers are able to detect them early on, they will pass by Earth without us even knowing they were there. To address this challenge, the astronomical community is developing new tools and techniques to scan the sky in search of interstellar objects. For one, a wide range of observatories are being repurposed or newly designed to capture these fleeting visitors. Pan-STARRS, the telescope that first discovered Oumuamua, has been part of this effort, but additional observatories and telescopes will be needed to provide comprehensive coverage of the sky. One of the most notable upcoming projects is the Rubin Observatory, set to be fully operational in the next few years. The observatory's cutting-edge technology will allow astronomers to scan the entire sky, detecting faint and fast-moving objects that might otherwise go unnoticed. Its ability to monitor the sky regularly and continuously, while providing high-resolution imaging, will make it a key asset in the hunt for interstellar visitors. In addition to new telescopes, the next frontier in discovering interstellar objects involves advanced algorithms and artificial intelligence, AI. The sheer volume of data generated by these surveys is staggering, and manual analysis is often not enough to catch every anomaly. By using AI to process and identify unusual trajectories or velocity patterns that match the characteristics of interstellar objects, astronomers will be able to sift through massive datasets more effectively and efficiently. This technology will enhance the ability to catch objects as they enter our solar system, giving us more time to study them before they slip beyond our reach. Another area of advancement that will significantly improve our chances of detecting interstellar objects is the development of dedicated space-based observatories. While Earth-based telescopes have the advantage of being large and capable of observing large swaths of the sky, they also face challenges like atmospheric interference and the limitations of location. A space-based observatory, one that can be placed in orbit or beyond Earth's atmosphere, would provide uninterrupted views of the cosmos. By positioning a telescope outside the Earth's atmosphere, astronomers would avoid the blurring effects of the atmosphere, which can distort images and reduce the clarity of observation. Such observatories could be placed in orbit around Earth or even further out into space, providing a more direct and precise look at objects as they travel through our solar system. While these technological advancements are certainly exciting, it's important to recognize that the discovery of interstellar objects is only part of the picture. The real challenge, and the real reward, lies in what we do with the data we gather. In the case of Oumuamua, scientists were left to speculate about its nature, origin, and significance. Because the object was so fleeting, the opportunity to study it in detail was limited, and by the time astronomers had gathered enough data, it was already too far to reach with existing technology. This was a reminder of the need for future space missions that could directly explore interstellar visitors. In the coming decades, it's possible that humanity could send spacecraft to intercept and study interstellar objects. While such missions are not yet feasible with current space technology, there is growing interest in pursuing this ambitious goal. Intercepting an interstellar object would require the development of advanced propulsion technologies capable of reaching high speeds, as these objects can travel at speeds far greater than anything within our solar system. Solar sail technology, for example, which uses the pressure of sunlight to propel spacecraft, could be a potential candidate for such missions. By deploying a solar sail on a spacecraft, it could be propelled across interstellar distances at speeds much faster than traditional propulsion methods, making it theoretically possible to catch up with an interstellar object before it passes too far beyond reach. Moreover, space agencies around the world, such as NASA, the European Space Agency, ESA, and others, are already exploring the possibility of missions that could be designed to intercept and study these objects. In 2021, for instance, a NASA scientist suggested that a dedicated mission to study an interstellar object might be launched in the future, following the path of objects like Oumuamua and Borisov. These types of missions could include sending specialized probes to capture detailed data on an object's composition, structure, and even its potential to host biological material. Such missions would represent a new chapter in humanity's journey to explore the unknown, and they would serve as a testament to the enduring curiosity and ambition of space exploration. As we prepare for such missions, the study of interstellar objects will likely help shape the future of interstellar exploration. If scientists can successfully intercept an interstellar visitor, it could be the first step towards sending humans to study distant star systems directly. This goal may sound far-fetched, but the study of interstellar objects offers the unique opportunity to learn about the materials, chemicals, and conditions that exist far beyond our solar system. It could pave the way for future technologies and methodologies that will allow us to venture further out into the galaxy, exploring stars and planets that are light years away. One of the most fascinating possibilities that interstellar objects like Oumuamua present is their potential to act as messengers from other civilizations. While most astronomers remain cautious in their interpretation of such objects, the discovery of these visitors from distant star systems has reignited the search for extraterrestrial intelligence. Oumuamua's bizarre characteristics, its cigar shape, rapid acceleration, and absence of typical comet-like behavior, have led some scientists to speculate that it could be an artificial object. Although the consensus is that the object is likely a natural body, the very fact that it has sparked such debate underscores the importance of continuing the search for intelligent life beyond Earth. As our tools and understanding of space evolve, the possibility of detecting artificial objects from distant civilizations may no longer be confined to the realm of science fiction. And as we look ahead, the ongoing discovery of interstellar objects may provide the first pieces of the puzzle in answering the ultimate question: are we alone in the universe? If objects like Oumuamua are traveling between star systems, it's possible that other civilizations are also exploring the galaxy, sending probes and messages across vast distances. just as we now send our own spacecraft to explore the stars. These objects could be the messengers of civilizations that are far older and more advanced than our own, and studying them could reveal unexpected insights into the technologies, cultures, and histories of other beings. Whether these objects are artificial or simply natural debris, the fact remains that they provide us with an unprecedented opportunity to explore the broader structure of the galaxy and perhaps, just perhaps, discover that we are not alone in the vast expanse of space. Ultimately, the future of interstellar object discovery holds enormous promise for humanity's exploration of the universe. The scientific, technological, and philosophical implications of studying these objects will likely shape space exploration for generations to come. As astronomers refine their tools, develop new methods for detection, and explore new avenues for space missions, the discoveries that await us will continue to challenge our understanding of the universe and our place within it. The journey that began with Oumuamua is just beginning, and it promises to take humanity further into the mysteries of space than we've ever imagined. As we look to the future, the discovery of interstellar objects like Oumuamua and 2I is reshaping how we think about the universe, our place in it, and the very nature of life itself. These interstellar visitors have already started a revolution in the way we study space, and their continued presence will likely drive some of the most exciting and challenging discoveries in the years to come. But beyond the immediate scientific implications, the question that lingers is, what does it all mean for humanity's broader journey in the cosmos? The implications of these discoveries extend far beyond the realm of astronomy. For the first time, we are being confronted with the reality that the universe is not just a collection of isolated star systems, each functioning as a separate entity within its own gravitational bubble. Instead, interstellar objects suggest a much more interconnected, dynamic structure, a galactic network where material, energy, and possibly even life itself can travel freely between stars. This realization challenges long-held assumptions about the nature of our existence, forcing humanity to reconsider its isolation in the cosmos and reflect on the possibilities that await as we look further into the stars. One of the most profound consequences of the discovery of interstellar objects is the shift in how we view the potential for life elsewhere in the universe. For centuries, the question of whether we are alone in the galaxy has been one of the most pressing and existential concerns for humanity. The discovery of Oumuamua, followed by other potential interstellar visitors, has opened the door to the possibility that life, whether microbial or intelligent, could exist far beyond Earth. The idea that life could travel across vast distances, hitching a ride on comets, asteroids, or other space debris, brings new depth to the search for extraterrestrial life. In particular, the theory of panspermia, the hypothesis that life or the building blocks of life could be transported between planets, star systems, or even galaxies by cosmic debris, has gained new traction in light of these discoveries. The idea that life could spread across the universe, not confined to one particular star system but distributed by the movement of material, is no longer a theoretical concept, but a real possibility. If interstellar objects like Oumuamua can travel across the vast distances between stars, it stands to reason that life or the precursors to life could also be carried by these cosmic wanderers. This opens up the tantalizing possibility that life could be far more widespread in the universe than previously imagined. Moreover, the potential for life to travel between star systems could have profound implications for our understanding of the origins of life on Earth. Could our own planet have been seeded by material that arrived from another star system, carrying with it the raw ingredients necessary for life to begin? While this remains speculative, the discovery of interstellar objects gives this hypothesis a new scientific context. It suggests that life might not be an isolated phenomenon, bound to a single planet or star system, but rather a dynamic and interconnected force capable of spreading across the galaxy. Yet, while these discoveries may suggest that life could be more common than previously believed, they also highlight the complexities and challenges that come with studying life beyond Earth. Even if we accept that life could travel through space, the question remains, how do we detect it? The search for extraterrestrial life has traditionally focused on finding habitable planets or moons within specific Goldilocks zones, areas where conditions are just right for liquid water to exist. But as our understanding of interstellar objects deepens, it becomes clear that life may not be confined to these narrow zones. Life could exist in a broader range of environments, perhaps in places we haven't yet thought to look. This insight will likely push the boundaries of the field of astrobiology. As scientists continue to study interstellar objects, they will not only look for clues about the physical characteristics of these objects, such as their composition and behavior, but also search for signs of biological material. In the coming years, missions may be designed to intercept and analyze these objects more closely, seeking to understand whether they contain organic compounds, microscopic life, or other indicators of life's existence. These missions could help scientists determine whether interstellar objects are simply inert pieces of cosmic debris, or whether they are something much more significant, messengers carrying the building blocks of life, or perhaps even life itself. In addition to the search for life, the study of interstellar objects will continue to broaden our understanding of the structure and evolution of the galaxy. For much of human history, we've regarded the Milky Way as a collection of isolated star systems, each with its own planets, moons, and satellites. However, the discovery of interstellar objects tells a different story, that the galaxy is not a static, isolated collection of stars, but a dynamic, interconnected system where material moves freely between stars, sometimes in the form of comets, asteroids, or even fragments of planets. These objects are a key to understanding the larger cosmic environment, revealing how stars and planets interact, and how material flows between different parts of the galaxy. The arrival of Oumuamua has already forced astronomers to reconsider the way they look at the solar system and the galaxy as a whole. These objects have shown us that the solar system is not an isolated island in space, but part of a much larger, more complex galactic network. And as astronomers develop new technologies and refine their methods for detecting and studying interstellar objects, they will gain deeper insights into the processes that shape the galaxy, including the formation of stars, planets, and even entire solar systems. These discoveries could help us understand the evolution of our own solar system, shedding light on how our planet came to be, and what role the broader cosmic environment played in shaping life on Earth. Yet, as important as these scientific advances are, they also raise deeper philosophical and existential questions. The realization that the galaxy is filled with interstellar objects, constantly passing through our solar system, forces us to reconsider our sense of isolation in the cosmos. For millennia, humanity has believed that Earth is unique, that our planet is a special place in the vast, empty universe. But the discovery of these cosmic wanderers suggests that Earth is not alone in the galaxy, that we are part of a much larger and more interconnected network. This realization has profound implications not only for the field of space exploration, but also for our understanding of our place in the universe. Are we truly alone? The answer to this question may seem elusive, but the ongoing discoveries of interstellar objects suggest that life could be more widespread than we ever thought possible. The fact that objects from other star systems are regularly passing through our solar system is a reminder that the universe is not static, but constantly in motion. It suggests that we are not isolated in a quiet corner of the galaxy, but part of a much larger cosmic system, where material, energy, and even life itself can move freely across vast distances. Perhaps the most profound takeaway from the discovery of Oumuamua and other interstellar objects is the way it forces us to think about the future of space exploration. We've long dreamed of traveling to distant star systems, but these objects provide an unexpected shortcut. They are like cosmic breadcrumbs, pointing the way to the larger mysteries of the galaxy. As technology advances and we develop new methods for detecting and studying these objects, we may find ourselves not just observing the stars, but actively engaging with the galaxy itself. These objects could serve as stepping stones on our journey into the wider universe, helping us unlock the secrets of distant star systems, understand the conditions that make life possible, and perhaps even make contact with other civilizations. The future of space exploration is no longer confined to our solar system. The discoveries of the past few years have expanded the horizons of space science, revealing that the universe is much larger, more dynamic, and more interconnected than we ever imagined. And as we continue to explore these interstellar visitors, we may just find that the answers to our biggest questions are not as far away as we once thought. The search for life, the quest to understand the nature of the cosmos, and the dream of venturing beyond our own solar system are no longer distant goals. They are within our reach, thanks to the discoveries we are making today. In the end, the discovery of interstellar objects is just the beginning. The future of space exploration holds exciting opportunities to further unravel the mysteries of the galaxy, to explore new worlds, and to answer the most profound questions about life and existence. As we continue to study these cosmic wanderers, we may just discover that the universe is far more interconnected and full of wonder than we ever imagined, and in doing so, humanity's journey into the stars will take its next great leap. As we move deeper into the 21st century, The discovery of interstellar objects like Oumuamua and 3IATLAS continues to shape the trajectory of space exploration and our understanding of the universe. While these objects may have seemed like fleeting anomalies at first, they are part of a growing recognition that the cosmos is far more dynamic and interconnected than we once thought. What began as a curiosity about strange visitors from the depths of space has become a catalyst for a deeper and more profound investigation into the origins, nature, and future of cosmic wanderers. But beyond the immediate excitement of astronomical discoveries, one of the most profound implications of these interstellar visitors is the way they force us to reconsider the very nature of existence and our place in the universe. In the wake of Oumuamua's unexpected visit, a profound realization began to settle in. The universe is not as empty as we once thought. For centuries, the space between stars was considered a barren, lifeless void, an expanse so vast and inhospitable that it seemed impossible for anything to travel between stars. Our solar system was perceived as a singular, isolated system, with little to no interaction with the broader galaxy. But the arrival of Oumuamua shattered that assumption. This object, moving at incredible speeds and on a hyperbolic trajectory, was not bound by the sun's gravitational pull, and it wasn't native to our solar system. It had arrived from somewhere else, from another star system entirely, bringing with it a message that humanity would not soon forget. The universe is full of travelers. As Oumuamua made its brief, dramatic pass through our solar system, it became clear that objects from other star systems, whether they are fragments of planets, comets, or perhaps even alien probes, were not as rare as we had once thought. And as technology advances, astronomers have come to realize that Oumuamua may not have been a solitary visitor. It could be the first of many interstellar objects to come, part of a larger, still mostly unexplored phenomenon. The question now is not whether we will encounter more interstellar visitors, but when and how often we will encounter them. As this knowledge begins to sink in, the study of these objects has become one of the most exciting frontiers in modern science. One of the most striking aspects of this realization is the way it reframes our understanding of our solar system's place in the galaxy. For centuries, Earth was viewed as a small, relatively insignificant planet orbiting a medium-sized star, tucked away in the outer reaches of the Milky Way. Our understanding of the universe was confined to the idea that our solar system was isolated, and that the vast distances between stars made any meaningful interaction with other star systems highly unlikely. The discovery of Oumuamua and other interstellar objects has changed this view entirely. It is no longer accurate to describe our solar system as an isolated island in space. We are, instead, part of a much larger cosmic ecosystem, one in which material from distant star systems can move freely across vast distances, and in which our solar system is part of a galactic network. This new understanding forces us to think about the universe in a much broader context. If material, whether in the form of dust, asteroids, or larger objects, can travel between stars, then the space between stars is not as empty as we once thought. It is a dynamic region where cosmic material, energy, and possibly even life itself can be exchanged. The realization that the universe is filled with such material exchanges opens up new possibilities for the study of the cosmos. If we can detect and study interstellar objects as they pass through our solar system, we might learn more about the conditions that shape distant star systems, and perhaps even uncover clues about the nature of life itself. As astronomers look ahead to the future, one of the most exciting areas of study will be the ongoing search for interstellar objects. While Oumuamua was the first confirmed interstellar visitor, astronomers have begun to think about the many other objects that could be out there, waiting to be discovered. With the technology currently at our disposal, and the advancements being made in astronomical observation, we can expect that more interstellar objects will be identified in the coming years. These objects could take many forms. Some may be like Oumuamua, tumbling through space at high speeds with mysterious properties, while others may resemble more traditional comets or asteroids. Each one, however, represents a piece of a much larger puzzle, offering a glimpse into the broader processes that govern the formation and evolution of star systems. The next major step in this field of study will be the development of new technologies to detect and study these objects. As mentioned previously, space-based observatories like the James Webb Space Telescope (JWST) and the Vera-Rubin Observatory will play a significant role in this effort, allowing astronomers to monitor the sky with unprecedented sensitivity and precision. These observatories will provide real-time data on the movement of objects through our solar system, helping scientists track their trajectories and composition. Additionally, advancements in artificial intelligence and machine learning will allow for more efficient analysis of the vast amounts of data generated by these observatories. By using AI to detect subtle patterns in the movement and behavior of interstellar objects, astronomers will be able to identify and study these visitors with greater speed and accuracy. As we continue to refine our ability to detect interstellar objects, we will likely see an increasing number of space missions designed to intercept and study these objects up close. While this may seem like science fiction, it is quickly becoming a realistic goal for the future of space exploration. Spacecraft capable of traveling to and studying interstellar objects would be among the most ambitious missions ever undertaken, but they hold the potential for groundbreaking discoveries. These missions could reveal valuable information about the composition of these objects, their origins, and the conditions that exist in distant star systems. If interstellar objects carry organic material or signs of life, the implications for the search for extraterrestrial life would be immense. These objects could serve as messengers from distant worlds, providing insight into the building blocks of life and the potential for life elsewhere in the universe. But the study of interstellar objects isn't just about finding life, it's also about understanding the broader dynamics of the galaxy. The movement of material between star systems is a fundamental aspect of the galaxy's structure, and by studying interstellar objects we can gain insights into how stars and planets form and evolve. These objects are, in many ways, relics of their parent star systems, carrying with them information about the processes that shape their worlds. By analyzing their chemical compositions, scientists can learn more about the conditions in distant star systems and how those conditions might be similar or different to those in our own solar system. This understanding also has profound implications for the study of our own solar system. By studying interstellar objects, astronomers can gain a better understanding of the forces that shape our solar system, how it interacts with its galactic environment, and the potential for life to exist elsewhere in the galaxy. Interstellar objects are like cosmic time capsules, offering a snapshot of the broader processes that govern the universe and providing a glimpse into the past of distant star systems. As we study these objects, we gain not only a better understanding of where we come from, but also where we might be headed. However, the study of interstellar objects also forces us to confront the deeper questions of existence, questions that have puzzled humanity for centuries. If life can travel across the galaxy, then the boundaries between life and non-life, between the Earth and the cosmos, become less clear. Are we part of a broader cosmic ecosystem, where life is constantly spreading and evolving across the galaxy? Are we alone, or are we just one piece of a much larger puzzle that spans across the stars? These are questions that have no easy answers, but they are questions that we must grapple with as we continue to explore the mysteries of the universe. In the end, the discoveries of interstellar objects like Oumuamua and 2I have opened up an entirely new frontier in space exploration. These objects are not just strange visitors from distant star systems, they are messengers, providing us with valuable insights into the structure of the galaxy, the origins of life, and the possibility of life beyond Earth. As we continue to study these cosmic wanderers, we may find that the universe is far more interconnected, dynamic, and full of life than we ever imagined. And as we journey further into the stars, we will be reminded that the search for knowledge, for understanding, and for connection is an eternal quest that spans across the universe itself. The discoveries of interstellar objects like Oumuamua and 2I mark a turning point in humanity's understanding of the cosmos and our place within it. These objects, unexpected visitors from other star systems, have shattered the long-held assumptions that our solar system is a static, isolated body in the universe. Instead, we are confronted with the reality that our solar system is part of a far larger, interconnected cosmic system where material, energy, and even the potential for life can flow freely between stars. The implications of these discoveries are not only profound for the field of astronomy, but for humanity's broader existential understanding of the universe. Oumuamua's passage through our solar system ignited a firestorm of scientific inquiry, forcing researchers to re-examine the assumptions they had about interstellar objects, their origins, and their potential significance. Initially considered an anomaly, Oumuamua's strange characteristics, its elongated shape, erratic acceleration, and unexplained behavior, led to speculation that it might be an artificial object. Although the consensus remains that it is a natural body, its appearance raised fundamental questions about the possibility of extraterrestrial intelligence, and opened the door to new theories about life and technology in the universe. The debate sparked by its presence was not just about the object itself, but about what it represents, the possibility that intelligent civilizations might exist beyond our own, communicating with us in ways we haven't yet fully understood. Beyond the question of intelligent life, the arrival of interstellar objects has had a dramatic impact on our understanding of the broader structure of the galaxy. These objects are not isolated. They are part of a constant flow of material between star systems, traveling through the vast spaces between stars as if the galaxy is an interconnected web rather than a series of isolated islands. As we begin to detect more of these visitors, we are forced to confront the reality that space is not empty, but teeming with potential knowledge, material from distant stars, the remnants of long-dead planets, and the possibility of microbial life traveling across light years of space. The movement of material between stars reshapes our perception of the universe and challenges the notion that our solar system is the only significant point in the vast expanse of space. The next chapter of space exploration, one that is already beginning to take shape, will be focused on understanding the broader cosmic environment that these interstellar objects represent. With the technology available to us today, and with the advancements we are likely to see in the coming decades, humanity will embark on an unprecedented journey to detect, study, and potentially interact with more interstellar visitors. The quest for knowledge will expand from studying the objects within our solar system to looking outward, seeking to understand the forces and processes that govern the galaxy and even the larger universe. In this new age of exploration, the study of interstellar objects will serve as a gateway to understanding not only the nature of other star systems, but also the potential for life beyond Earth. The theory of panspermia, the idea that life can travel between stars on comets or other debris, has been given new weight by these discoveries. If material can flow between stars, it follows that life, or at least the ingredients necessary for life, could be transported across vast distances. This revelation has profound implications for the search for extraterrestrial life, expanding the scope of our search to include not only planets and moons but also the cosmic debris that travels between them. Moreover, the discovery of these objects pushes the boundaries of our philosophical understanding of the universe. Humanity has long pondered whether we are alone in the cosmos, and while the discovery of Oumuamua and 2I hasn't provided definitive answers, it has opened up the possibility that life is far more widespread than we ever imagined. It challenges our sense of isolation, offering a glimpse into a universe that is teeming with possibility. This realization forces us to ask difficult questions about the nature of life, intelligence, and our place in the grander cosmic picture. As we look to the future, the study of interstellar objects will likely remain one of the most exciting and profound areas of research. The tools we have today, such as the Pan-STARRS telescope, the James Webb Space Telescope, and the Vera C. Rubin Observatory, are just the beginning. With new telescopes, advanced data processing technologies, and increasingly sophisticated missions designed to intercept and study these objects, the next generation of space explorers will have the opportunity to delve deeper into the mysteries of the galaxy than ever before. But it is not just the scientific implications that are important. The discovery of interstellar objects reminds us of the inherent curiosity and drive that defines humanity. It challenges us to push beyond our limitations, to look beyond our solar system, and embrace the mysteries of the broader universe. It is a call to explore not just the stars, but the deep questions about existence, life, and our place in the cosmos. The search for knowledge is an eternal journey, and as we continue to uncover the secrets of the universe, we are reminded that we are all part of a much larger, much more interconnected story than we had ever imagined. In the end, the discovery of interstellar objects like Oumuamua and 2I is more than just a scientific breakthrough. It is a milestone in humanity's journey toward understanding the vastness and interconnectedness of the universe. These objects serve as reminders that we are not isolated, that the universe is not static, and that the questions we have about life, the cosmos, and our place in it are far from over. As we continue to explore the stars, we will find that the universe is far larger, more complex, and more interconnected than we could have ever imagined. And with each new discovery, we are one step closer to understanding the true nature of the cosmos and our role within it. The journey has just begun.